this exercise will be looking at a question involving some money problems, percentages, unit conversions, limits of accuracy, and some algebra. So remember, we provide these exercises compiled into a booklet. So you can contact us to get the booklets so that you can attempt to do the questions on your own first, so that when you get stuck, and then you can come to watch the revision videos. Okay, let's move on with the question. We're told that Jane works in a post office, and then we're told again in number A that the table shows the costs of sending parcels by post. The cost depends on the mass, grams, of the parcel. So in this table, we have the type of parcel: small, medium, large, extra large, and then the mass, and then the cost. So what we see here, remember, this reads as m, which is the mass, is greater than 0 but less or equals to 60. This means a parcel which is considered small is greater than 0 in mass up to a mass of 60 grams, and then a parcel which is considered as medium should be above 60 but less or equals to 100, and then these are the corresponding costs. All right, and then number A of the question, Roman figure 1. Tom sends each of these 4 parcels by post, and then there's a 55 grams parcel, 0.3 kg parcel, 875 grams parcel, and 250 grams parcel. And then we're told he pays with a $20 note. Work out how much change he receives. So that's what we can do. We can find how much each of these parcels would cost to post, or rather to send by post. So the 55 grams will be in this range, of m is greater than 0 but less or equals to 60, meaning this parcel here would cost $0.76 or 76 cents to send. And then 0.3 kgs. Remember, these costs are for these masses in grams. So here we'd have to first convert the 0.3 kgs into grams. So remember, 1 kg is equals to 1000 grams. So using cross multiplication, we'll put 0.3 under 1 kg and then do the cross multiplication. That is 0.3 multiplied by 1000 divided by 1 kg. So that would give 300 grams. That's 0.3 by 1000, 300 grams. So this is actually 300 grams. So the mass 300 grams, let's find out in which range it will fall into. 300 grams, this is above 200 up to above 250 up to 1000. So 300 grams will fall here, meaning to send this parcel 0.3 kg will cost $5.60. So let's write that here, $5.60. And then 875 grams will be in this range, above 250, less or equals to 1000. So this would also cost $5.60 to send. And then 250 grams will be in this range, since in this range the masses here are above 100 but less or equals to 250, and this is exactly 250, so it will cost $2.20 to send. So now that we have identified the cost of sending each parcel, remember this guy pays with a $20 note. So in order to work out how much change he receives, this is what we can do. So doing all of this will be worth 4 marks. He's going to pay with $20, And then from the $20, we're going to subtract the sum of each of these amounts here, meaning 0.76 plus 5.6 plus another 5.6 plus $2.20. So we can just work all of these out in a calculator. So that's what we can do. We have $20, and from that we need to subtract the sum of the amounts he will pay for each of these parcels. So it's 0.76 plus 5.60 plus another 5.6 plus 2.2 close bracket, and then we get $5.84. So this guy will pay $5.84 to send these 4 parcels, or rather this is the change he receives. Sorry, the amount he pays is the sum of these amounts, and then remember the question wanted the change he receives, so we'll subtract that sum from 20. So this is the change. All right, remember in figure 2 of the question, on 1 April, the cost of sending any parcel increases by 5%. Show that the increase in the cost of sending an extra large parcel is 0.28 or $0.28. So when a question says show that, you do a calculation that gives you this, or whatever that the question wants. So we first have to find 5% of the cost of sending an extra large parcel. So it should be 5% of, remember the cost of sending an extra large parcel is $5.60. So we want to find 5% of $5.60, which is, remember, a percentage of something is a number out of 100. Multiply that by 5.6, and then that's supposed to give us $0.28. So let's quickly confirm that with a calculator. So that's let's use a fraction here. That's 5 out of 100, and then you're supposed to multiply that by $5.60 or 5.6, and then this gives us 0.28, as you can see. All right, let's move on to number B. Avani says, as the cost of an extra large parcel increases by $0.28, then the cost of a large parcel will also increase by $0.28 to $2.48. Explain why Avani is incorrect, meaning this statement by Avani is not correct. So we can do a calculation to show why Avani is not correct, because she's claiming that if the cost of sending an extra large parcel increases by 0.8, then the cost of sending a large parcel will also increase by 0.8. So let's show that she's incorrect. So what we can do, we can find 5% of the cost of sending a large parcel, so that we can show that 5% of sending a large parcel of the cost of sending a large parcel is not 0.28. So remember, to send a large parcel is $2.20. So working that out, we should get let's see, 5% using a fraction, that's 5 out of 100. 5 out of 100, multiply that by $2.20 or 2.2, that's $0.11. So it's actually 11 cents. So we can conclude our explanation by saying 5% of $2.20 is not 28 cents. It's not 28 cents, meaning Avani is incorrect to say that the parcel of the increase in the cost of sending a large parcel is 0.8. So it's actually 0.11, not 0.28. So we have showed that or explained that by doing this calculations and then concluding that she is incorrect, as you can see here. All right, let's move on to the next part of the question. So in number B, Roman figure 1, we are told that Jane weighs a parcel with a mass W kg on her scales. She uses the masses shown to balance the scales. So this means on the left side she has a 2 kg mass, and then on the left side she uses 5 grams, 10 grams, 20 grams, and then W kgs. So the scale is balanced. Remember, she uses the masses shown to balance the scales, meaning the total mass on the left side is equal to the total mass on the right side. So what we can do to work out the value of W, we need to find how much is W. So since W is in kgs, we'll need to convert this 5 grams, 10 grams, and 20 grams into kgs as well. So to do that, what we can do, remember 1 kg is equals to 1000 grams, and then use cross multiplication to convert each of these masses in grams into kgs. So that's 5 grams. So you say 5 by 1 divided by 1000, meaning basically to convert from grams to kgs you divide by 1000. So 5 by 1 divided by 1000, that should give 0.005. It should give 0.005 kgs. And then we also have 10 grams. 10 grams divided by 1000 should give us 0.01 kgs. And then 20 grams as well. We need to find 20 grams, divide that by 1000. We get 0.02 kgs. So these are these masses in kgs, because we're going to form an equation here which equates the left hand side to the right hand side. So this is what we'll do. We know that the mass W in kgs together with the total mass of these masses, that is the 5 grams, 10 grams, and 20 grams, all of them, they should be equal to 2 kg. So we'll put in these masses, but remember we have converted them to kg, so we'll write 0.005 here plus 0.01 plus 0.02, and then all of this should be equals to 2 kg. So we can grab calculator quickly to work out this sum. So we have 0.005 plus 0.01 plus 0.02. So this gives 0.035. So this will be 0.035. Sorry, that is not the answer, but only part of the working. So this is W plus 0.035, and then everything should be equal to 2. So as you can see here, in order to find W, we should subtract 0.035 from both sides, meaning W will be, remember, if we subtract 0.035 in this case, we'll end up with 0, because we'll say 0.035 minus 0.035, so that will leave only W on the left hand side. So on the right hand side, we'll say 2 minus 0.035. So that should be 2 minus 0.035. That's 1.965. So that will be the answer, 1.965. All right, let's move on to Roman figure 2 of this question. So we're told that sometimes Jane uses an electronic weighing machine. The machine gives masses p kg, p stands for the masses, of a parcel as 12.4 kg correct to the nearest 100 grams, meaning the scale, the electronic scale that Jane is using, gives answers correct to the nearest 100 grams. So the question says complete this statement about the value of p. So as you can see, this is a statement for the limits of accuracy for these masses p kg, meaning we have to find the lower bound on this side and we also have to find the upper bound on this side. So what we need to do, notice that some parcel, we were told it was its mass was displayed on the electronic scale as 12.4 kgs, and it is known that the electronic scale gives readings which are correct to the nearest 100 grams. So in order to find the limits of accuracy using this information, the degree of accuracy here, which is the 100 grams, we'll have to convert it into kgs so that we can be able to find the limits of accuracy. So what we can do, since the masses are displayed in kgs, but then we know they are around at 200 grams, to find the limits of accuracy, let's convert this 100 grams into kgs. So you remember from earlier that to convert between kgs and grams, you use 1 kg, it's equals to 1,000 grams, meaning to convert mass in grams into kgs, you're going to divide by 1,000. So 100 divided by 1,000, that should give us 0.1 kg. 0.1 kg, meaning the answers, or rather the masses displayed on the electronic weighing machine are correct to the nearest 0.1 kg. So now that the degree of accuracy is also in kgs, we now divide that degree of accuracy 0.1 by 2. So dividing 0.1 by 2 will get 0.05. So this 0.05 is what we will subtract from 12.4 to get the lower bound, and then add it to 12.4 to get the upper bound. So this means to get the answer which is supposed to be here, which is the lower bound of these masses, the lower bound, to find the lower bound, that's what you will do. You'll say 12.4 minus 0.05. If you quickly work that out on a calculator, you are supposed to get 12.35 kgs. So your lower bound on the side will be 12.35. And then for the upper bound, that is 12.4 plus 0.05. So that is 12.45. 12.45. So the upper bound will be 12.45. So that's how you do these kinds of questions. So remember, the degree of accuracy, you divide it by 2 to find what will you subtract from the value that you were given to get the lower bound. And then also what you get when you divide the degree of accuracy by 2, you add that to the number that you are given to find the upper bound. But remember, if the units are not the same here, make sure that this unit, you first convert it into the unit that you are given here. Alright, that is all for this question or this exercise.